Okay, hello again everyone. So this video is a video on the description of the further description on your task A3, where this is a part of data preprocessing, selecting important data, or we can call it as feature selection. Now, in your data set or in your features or in your attribute, some of those features are matters, some of them are don't. So they can be classified as relevant features, irrelevant features, and also redundant features. So what are relevant features? Those features are prominent and those that we need to perform well. What is it that we want to perform here? So it is actually talking about our what we call as our model. Okay. So this is talking about our model to perform well in terms of what? In terms of accuracy, for example. Okay. Next, we have irrelevant features, meaning that those features are simply unnecessary or it will hurt the performance of our model. Okay. Or it will reduce the accuracy. Okay. Instead of increasing, it will reduce it. Why? Because sometimes some of the features are noisy. Okay. Then we have also redundant features here. Redundant features are those that become irrelevant in the presence of others. Okay. Or those that only show their worth in the context of others. Okay. So for example, we have features A1 here and we also have features A2 here. Okay, so for example, we have date here in term of 1/1/2011, and then this one we have January. Okay, for the row here. Okay, so these two features are actually redundant features. Okay, because these features are actually irrelevant with the presence of A1 because it is the same thing here. Okay. We know that from here it is January and this is January as well. Okay. Next is the benefit of feature selection. Why we need to do the feature selection or reduce some features. Okay. This is to reduce overfitting. Less redundant data mean less opportunity to make decision based on noise. Okay. So some features, just like I said before, some features are noisy features. Okay. Then we are going to have improvement in the term of accuracy, where less misleading data means modeling accuracy will improve. So this is noisy as well. Okay. Next is it will reduce the training time. Less data means training process is more efficient. So for example, we have 1 million of data set or 1 million of features here. Okay. 1 million of features, if we reduce them into 500 features only. Okay. Can you imagine how much time that we can reduce when we just use these 500 instead of 1 million features? Okay. So there are two methods of feature selection. One would be filter method. The second one is wrapper method. In filter method, a relevant score is assigned to each feature in the data set. Then they are ordered according to their relevant score or rank. So we have here features and we also have rank. These features, for example, we have A1, A3, A2. Okay. These features will have their own rank 0.7, 0.5, 0.1. Okay. In general, features with high score are selected. Okay. And low score features are eliminated. For example, we remove these features. Okay. Because it is very low. So in WEKA, we use info gain attribute eval here. So we need to go to select attribute tab and then choose here as info gain attribute eval. Later on, we will see them. Usually, okay, filter method will be used in data mining. Okay, with high dimensional data. If we have high dimensional data, for example, we have 1,000 or 100,000 of features. Okay, because filter method is when we want to reduce number of features. Okay. Next we have wrapper method. Wrapper method is will use specific classifier. Okay. First you have to choose wrapper subset eval here as the attribute evaluator, and then it will, if you double click here, okay, it will pop up this form, okay, and then the classifier will be chosen here. Okay, for example, the default one is 0R, and this classifier is being used to get the subset of features. Okay, so wrappers use a search procedure in a space of possible features, then it will generate and evaluate various subset. Okay, so meaning that you are going to have different subset of features if you do the wrapper method. Previously in filter method, okay, we rank them and then we get list of features, the best features. But now in wrapper method, for example, we have 10 features, A1, A2, A3, A4, up till A10, right? In wrapper method, we are going to get subset. Okay, subset. Some features will be in a subset. Okay, subset of features being used for us to get the improvement of accuracy. So later on, we will take a look at WEKA and how filter method is being implemented. Usually in data mining, we use filter method. In wrapper method, we are using it in machine learning method. Because in wrapper method, it cannot deal with high dimensional data. Okay, so you have WEKA here. So let us just open the file, go to credit G. Okay, select credit G. Okay, in credit G we have 21 attributes. Okay, with 1000 of instances or sample or example ataupun row. Okay, selalu kita panggil. And this is the class. The 21st attribute would be the class here. Okay. So credit G is actually data set of German credit. German credit meaning that kita nak dapatkan class whether it is a good credit punya holder ataupun bad punya credit card punya holder lah daripada situ. Okay, so first thing first, bila kita dah dapatkan, kita dah masukkan kita punya attribute here. Okay, kita cuba dulu masukkan dalam model kita, meaning that kita cuba without any selection of attribute, meaning that we are going to consider all of those attribute. Okay, so we will try to get the classification punya modeling, meaning that kita nak cuba dapatkan the accuracy here. So let us say we are going to choose J48 sama je. Okay, so we will start here. Okay, class is class. Okay, start here. So if we take a look at here, okay, our correctly classified instances would be 70%, 70.5%, ataupun kita boleh katakan accuracy kita adalah 70.5% by considering all of these features. But then 70.5% is still not good for us kadang-kadang kan. So kita tak rasa it is good. We can increase the accuracy by selecting those attribute using the feature selection. So first let us take attribute evaluator as filter punya method. So filter punya method kita akan pakai info gain attribute eval. Okay, usually dia akan pop up satu pop up, dia akan kata you kena pakai ranker. So just let it be ataupun pilih saja okay kat situ. Okay, so dia akan terus automatic kepada ranker dekat sini. Okay, still use the full training set, leave as it is. Okay, so our class here would be class. Okay, so let us start. Okay, so if we take a look at here, okay, di dalam filter punya method here, okay, apa yang berlaku adalah it will rank all of those attribute. Okay, so the first ranking adalah checking status. The second ranking is the third attribute, that is credit history with 0.04 value of rank. And then there are some attribute that don't have any rank, maknanya value dia kosong kat sini. Okay, and it will select all attribute here. 20 attributes including class would be 21. Why? Because it will show all of the attribute. Kalau kita keluarkan 6 to select here as -1. Kalau contoh kita kata, okay, I just want to have half of the attribute, so I am going to have 10 features only. Okay, so click OK here, change it in 6 to select, click OK, and then you can start again. Okay, there you go, you have 10 selected attribute here. Okay, with the same rank tu still sama. Okay, so once kita patah balik kepada this one, okay, we just say that okay, this ranking or this attribute doesn't give any ranking value. So what if, okay, what if we remove this from our data set? Okay, we remove this attribute from our data set so that we can see if there is any improvement of the accuracy here. Okay, so how to remove them? So we can go to preprocess again. Okay, what are the attribute existing? 18, 8, 11 and 16. Okay, we remove them. 18, 8, 11 and also 16 here. Okay, click remove. Okay, just now our accuracy is 70.5%. Now let us start classifying those tree again. Okay, using the tree model. Okay, take a look at this. The accuracy increases to 72% here. Okay, why? Because we have removed some of the irrelevant features. These irrelevant features sometimes it will hurt the model, whereby dia akan jadi macam noisy. Maknanya dia akan pening tau. Daripada 4 feature ni, mungkin dia akan pening dengan kewujudan this feature untuk dia try pecahkan tree, for example. Okay, so we see that the accuracy has increased to 2%. Okay, let us just remove, or we can use this 10 punya attribute here. For example, kita ambil 10 saja. Okay, so kita akan cuba remove the rest up till nombor 10 tu. Okay, so 19, nombor 10 apa, age. Okay, 14 other payment plan. Okay, we remove other payment plan here. And then what else can we remove? Personal status. Okay, personal status, foreign worker. Okay, foreign worker, other parties. Okay, and then job. Next is own telephone. Okay, so these will be removed. Then we are left with 10 attribute only, with 1 class attribute. Okay, let us run again the tree. Okay, classify, start it again. See, take a look at this. The accuracy has improved to 72.4% here. Okay, so you are going to do this what they call that experiment, whereby you are going to have a few features, okay, to be selected, and then you are going to run it again and again and again. So for example, you want to remove more features, further features. Okay, so you can remove it here, and then you try to classify it again. But then one thing that you must aware of is sometimes when you remove too much features, okay, it will also give you overfit, meaning that, for example, we have here iris data set here. Okay, so in iris data set we have 5 features here. Okay, 4 features. Okay, for X, and this is for class. The 3 features is class. Okay, So when we classify this one using G48, we have 96.96% of accuracy. Let us just select the attribute here, okay, using info gain, okay. So our class is class here, okay. Then we start, okay. When we start, okay, it say that number 3 and number 4, followed by 1 and 2, okay. 3 and 4 is the highest ranking, okay, followed by 1 and 2. So let us just say that, okay, I just want to remove features number 1 and features number 2. Okay, so let us remove this. Okay, remove. Okay, then we try to classify them again with these two features. Okay, take a look at this. The accuracy does not change. So this is why we say it is overfit, meaning that sometimes some features or some removal of features does not affect your accuracy here. Okay, so this is why in task A3, what I want you to do is you have to get two subset, okay, here, okay, select attribute and also the sample, okay. So you have to apply select attribute tab, okay. So you have to reduce the full data set, okay. So you need to explain your reduced data set, which features that you have been removed, why you are using what kind of filter, is it what kind of feature selection method, is it filter or is it wrapper, okay. And then you need to compare the result in terms of number of features, meaning that you need to go back to the classification model. You need to take a look at the accuracy value. Is it getting bigger or is it getting lower, the accuracy value? Then you have to save those reduced data set into file underscore reduce ARFF, and you need to screenshot all of them, okay. So usually what I want you to do is you need to compare the result between the full features and the reduced features. Is there any what they call that differences? For example, we have iris data set just now, okay. Iris data set, when we give or we select the features or we select the attribute, it won't give any differences in accuracy, but then it will be different with those credit G data set. Once you have removed some of the attribute, the accuracy will increase. So that's it. If you have any problem, you may ask me in WhatsApp group, or you can PM me later on. Thank you everyone. Bye.